Hello everyone. As part of learning generative AI, let us learn about transfer learning with pre-trained language models. So what exactly is transfer learning? It is one of the machine learning technique wherein you have developed a model for a specific task and you learned some knowledge out of that, or the model has learned some knowledge out of that. That can be used or that can be adapted in order to do another task which is related to the previous one. So we call this kind of approach as transfer learning, or to put it in short, the learning outcomes of the solutions or the learning outcomes of a particular task can be used in order to solve a different but a similar kind of task. Transfer learning is one of the building blocks for natural language processing and computer vision. So, what are the key concepts of transfer learning? Pre-trained models. Transfer learning often involves usage of pre-trained models and which have been trained on larger data sets. For example, we try to take help of BERT, GPT whenever you are trying to work with NLP, or ResNet and all whenever you are trying to work with computer vision tasks which are trained on huge amounts of data sets. And they have already captured the not only task specific knowledge, but they have also captured general features for a specific task. Next, fine tuning. Once we have identified which pre-trained model is to be used, generally we go for fine tuning on the specific data set. You have taken the pre-trained model, now you are trying to apply that to the data set which you are trying to use in order to solve the specific task. This involves retraining the model on the target data set with a smaller learning rate, because the pre-trained model has learnt on a huge amount of data set. Now you are trying to make the model learn from a specific data set, so you are trying to make it learn in a smaller learning rate, and it has to adjust all its weights based on the new task. And feature extraction, sometimes the pre-trained model can be used, just you use it as it is. Sometimes you can go for a new model which is tailored to the specific task. What are the benefits of using transfer learning? Reduced training time, because transfer learning is like already it has acquired some level of knowledge. Now you are just customizing it to the specific task. So you are trying to reduce the training time. You are also improving the performance in terms of you need not start the new task from the scratch, and you need not work with huge amounts of data set, because now you are working with a task which is narrowed down to a specific data set, and less data requirement. Whenever you are trying to work with transfer learning, the model has already got training on a huge amount of data set. Now it has to work on lesser amount of data set, wherein the requirement of data set is reduced. And what are the applications of transfer learning? Natural language processing. As I told, these are some of the pre-trained models like BERT, GPT, Roberta, etc., which are used in sentiment analysis. Most of the time we see applications, sentiment analysis in responses to social networking posts. So therein we can use all these pre-trained models. named entity recognition like tagging and text classification, right? Then computer vision, whenever you are trying to work with image data sets, working with a pre-trained model which has learned from large image data sets, you can still work with those models in order to work with a specific domain. Like, now don't read through all the images, read through only medical imaging, right? So transfer learning is a very powerful strategy which will try to improve the performance measures of a model, and it will take help of the knowledge which it has gained from related tasks, and it becomes the fundamental approach for many of the machine learning applications. Let us talk about one of the pre-trained models, BERT. It's bidirectional encoder representations from transformers. This language model was introduced by Google in 2018, which is giving a huge leap in the field of natural language processing. It is designed in order to understand the context of words in a sentence by leveraging the transformer architecture. What is bidirectional context? Whenever you are trying to predict the word which is suitable for a context, the BERT can read through the text in both the directions simultaneously. Suppose I am trying to work with a word, whether it is fitting into the context or not, I can see the relevance of that word by comparing it with its previous tokens, as well as comparing its relevance with the next level tokens or next tokens which are there on the successor positions. So it's bidirectional simultaneously. Transformer architecture. BERT is based on the transformer architecture. Self-attention, all those mechanisms are used here, and it will also try to see the importance of different words in a specific sentence, and it will also try to see the interdependencies between words in a specific sentence. Pre-training and fine-tuning. BERT undergoes the two main phases, which is pre-training as well as fine-tuning. Under pre-training, the model is trained across a large corpus of text data using two objectives. One is masked language model. As I told, you try to mask some of the words in the input text and the model has to predict them. Next sentence prediction. Whenever you are trying to train the model, it has to determine what could be the next sentence which is following the current sentence. Thereby it has to get trained on the sentence level relationships. Fine tuning. After pre-training, the BERT can be fine tuned on specific task. While working with pre-training, it is trained on huge amounts of data set. Fine tuning, you are making the model to get training on a specific task by applying whatever knowledge it has learnt onto the task which is very much narrowed down to a specific application. Multilingual capabilities. BERT has extended into multilingual versions, which is MBERT, which supports various languages, allowing it to perform all the NLP tasks. What are the applications? Text classification, named entity recognition, wherein you are trying to identify various entities like what is the person name, what is organization name, etc. Question answering, context based. Suppose there is a passage, you are trying to ask some questions and it is trying to give you the answers based on the context. Sentiment analysis, you are trying to determine based on the responses whether a particular person is responding to that in happiness, in sadness, what kind of emotion is there. Based on the response, you are trying to identify what is the emotion of the particular person, right? So BERT has set new benchmarks on various NLP tasks, and this has laid down the foundation for various models which are working in the NLP domain. What are the major advantages of BERT? It's bidirectional approach when it is trying to work with contextual relationships. Thank you.